welcome to Physics Chapter 2, One-Dimensional Motion Definitions. In this video, I'm just going to talk about the main definitions that we're going to be seeing in our problems, just so that you're familiar with them. I'll also go into basic formulas to tell you a little bit about them, and then we'll derive them in the next video. So first, if you see x, z, or x, y, z, or any of these variables, this just means position. Time is denoted by t. Delta means a small change. It could be a small change in time, distance, something like that. If you see x t1, this just means position at time t1. If you see x t2, this means position at time t2. So if you see delta x or change in x, this means x of t2 minus x of t1, and this essentially is just displacement. Displacement can be positive or it can also be negative. So displacement can be positive or negative. That'll be important in a minute. Let me clear this up. This is a parentheses, so I'll draw it again. We can also have change in time. So that'll be time 2 minus time 1. And this is just a time interval. So I'll write it as a time interval. Then we can get to average velocity. So let me clear the page and then I'll write it again. So average velocity, say, is denoted by VAVG equals change in x or change in position over change in time. Then we have displacement. Again, I'll rewrite it. Change in x equals average velocity times change in time. So when you see the word speed or the value speed, this just means how fast something is going. Now, the important thing about speed is that it's always positive. Speed cannot be negative. So speed is always positive. Now if you see the word velocity, velocity is a vector. We'll learn about vectors later in case you don't know about them yet. Vectors contain magnitude and direction. What does this mean? This means that velocity can be, and I'll change colors, positive or negative. That's the main distinction between speed and velocity. Speed is just how fast something is going, and it's always positive. And velocity is a vector. It can be positive or negative, so it has a magnitude and direction. So the formula for velocity will be displacement over time. And the formula for speed is distance over time. So we'll clear the page and go to the next part. Acceleration is denoted by A equals velocity at time 2 minus velocity at time 1, or change in velocity. It's just the parentheses, over time 2 minus time 1. You can rewrite that as A equals change in V over change in t, whatever is easier for you. And I will denote some of these in calculus notation because I have to, because I will be talking about instantaneous velocities and things like that. So instantaneous velocity is denoted by v equals the derivative of x over the or dx over dt, which is just the first derivative of position, and this dot notation just represents a time derivative. So this is equal to the limit as delta t approaches 0 of delta x over delta time or t equals dx over dt. So again, I'll make a note here. Time derivative can be represented by the dot notation. That'll be the first derivative. Second derivative will have 2 dots. Third derivative will have 3 dots, and so forth. And then they change. You can look them up. Displacement will be delta x, which is, let me clear this up, it's a little hard to read. So it will be delta x equals the integral of dx equals the integral of v dt. Acceleration is just a change in velocity with respect to time. So we can write that as a equals dv over dt equals, we can also write it as a second derivative of position. Again, I will be talking more about these in the following video. I would actually derive some of these so you'll see how we generate them and not just memorize them. We're not in the business of memorizing, we're in the business of learning and know how to derive all these formulas. See you in the next video.